Now we are going to talk about introduction in organic chemistry. Organic chemistry is a carbon chemistry, and it's very interesting that elemental carbon is not very wide existing element in the nature. So it doesn't even appear in the list of the most common elements in our Earth crust. But all living things consist of organic compounds. So all plants, animal, petroleum, fabrics, plastics, and other are made of carbon compounds. So why carbon is so special? Why carbon is in the middle of organic compounds? Some reasons for that. Carbon has four valence electrons, and it's able to create four very strong covalent bonds with almost every element. And it has ability to create chains and cycles. Very different structure and very long chains, and it forms strong bonds with oxygen, with hydrogen, with halogens, so on. And there are three types of bonding possible for carbon. It's single bonds, it's double bonds, and triple bonds. Simplest organic compound are hydrocarbons, compounds composed of carbon and hydrogen atoms only. Some hydrocarbons have only single bonds and appear as a chain of carbon atoms also bonded to hydrogen atoms. These hydrocarbons are called alkanes or saturated hydrocarbons. So the first one, alkane or alkanes, saturated hydrocarbons, they have carbon single bonded with other carbons atoms. So carbon, and you know that carbon has four valence electrons, so it forms four bonds. So we need four bonds for each carbon, and if it's hydrocarbons, carbon bonded with hydrogen. So we have chain of three carbon atoms here, which are single bonded, and rest of the bonds are the carbon hydrogen bonds. So you can see only single bonds in this compound. This is alkane. This is a way to show its structure, and of course you can show this as a molecular formula. So C3H8. Next type of hydrocarbons is alkenes. They are unsaturated hydrocarbons, so they have these double bonds between carbons. Let's say the same amount of carbons, so one, two, but we need double bond here to make it alkanes, and we remember four bonds for each carbon, so two already exists, need two more. Three already formed, need one more, and three here. So hydrogen, 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 and molecular formula will be C3H6. And you can see because of double bond between two carbons, there are less amount of hydrogens here. The next type of unsaturated hydrocarbons with triple bond between two carbons is alkynes. So alkynes. So three carbon, one, two, three. We need triple bond. So and the right carbon has only three bonds. Needs one more. Okay, and And this carbon, the second one is good, has 4 bonds, and this left carbon needs 3 more bonds. And its molecular formula will be C3H4. So this one is least unsaturated hydrocarbons out of all of them. Okay, let's repeat again. So hydrocarbons, hydrocarbons family. These are compounds which are composed out of carbons and hydrogens only. To divide them on alkanes, alkenes, or alkynes, you need to pay attention to the type of bonds between carbon. If there are only single bonds between carbons here, they are alkanes, saturated hydrocarbons. If there is one single bond between carbons, they're going to be unsaturated hydrocarbons, alkenes. And triple bonds gives us alkynes, more unsaturated hydrocarbons. So let's go further. Okay. Hydrocarbons can have a straight, branched, or cyclic carbon chain. This is actually the thing that makes carbon very, very specific, and that is why carbon forms a huge amount of organic compounds. So the first one, we have here straight chain alkane. Now, why alkane? Because it only has single bonds. Why straight chain? Because you can see that all carbon bonded together one by one. 1, 2, 3, 4, 5, 6. So it's 6 carbons chain. Here in the middle we have not chain, but it's chain which connected in a cycle. So it's cycle out of 6 carbons. See? And pay attention. Yes, it's saturated too. It's cyclic alkane. It's saturated. No double or triple bonds here. That's why it's alkane, but it's cyclic because it's not a chain, it's cycle. And this one, the right one, 1, 2, 3, 4, 5, 6, 7 out of 7. So it's branched chain alkane. Alkane because of single bonds between all carbons, but branched because it's not only one line of carbons. It's a kind of some carbon which goes out of this chain, so it's branched chain. But these are still saturated carbon hydrocarbons because of single bonds between all carbons atom. So let's write a molecular formula for each of compound. So the first one, the left one, has 1, 2, 3, 4, 5, 6 carbon. That gives us C6, and we can calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 carbons. The right one, I would say it's C7 and H16. How do I know so fast that it's gonna be 16 hydrogens here? Because there is a formula for straight chain alkanes to define the number of hydrogens in every molecule. You need to use this formula CnH2n plus 2. So n is gonna be a number like 1 2, and so on. So for number 7, so let's do this. 7, and the amount of number of hydrogen atom will be calculated like this: 2 multiplied by 7, 2 times 7 plus 2. That gives us exactly 16 hydrogens. So alkanes have this general formula. What about cyclic alkanes? 6 carbon and 12 hydrogen gives us CnH2n formula. Please memorize this. For alkanes, it's going to be CnH2n plus 2, and for cyclic alkanes, it will be Cn2 or I'm sorry, 2n. I'm going to erase it. Okay, let's do concept checking. The first one, you need to circle organic compounds. So organic compounds, it's compounds which have carbon, not only carbon oxides, any types, carbon monoxide or carbon dioxide. So they are not going to be organic. So you can see CO2, it's carbon dioxide. It has carbon, but it's not organic, because organic compounds has carbon except of carbon oxides. So the first one, no carbon here, no organic. It's not organic compound. H2O, it's water, non-organic compound. Here we have organic compound, CH2, chlorine 2. So yes, it's organic. P2O5, no carbon here, no, it's inorganic compound. CH4 has carbon, it's not carbon oxide, so yes, it's organic compound. C3H8O, yes, it's organic, has carbon, no carbon here, has carbon. Okay, let's do another one. Consider the molecules of propane, propene and propyne. So we will need to do this. And yes, I think like this. Let me show you. Yeah, I think. I will put this link in your notes or in your learning models. You can see that there are name of compounds of organic molecules according to number of carbon atoms. So propane will have 3 atoms of carbon in its molecule. Let's say methane is CO4, CH4, 4. Ethane, 2 carbons. Butane, 4 carbons. Pentane, 5. Hexane, 6 carbon. Heptane, 7. And you already know these prefixes like hepta, penta, yes, octa. We already met them when we trained to name covalent compounds. So, and I will put this information in your learning model. So, okay, let's go back to your concept checking. So propane has to have 3 carbons in molecules. So propane saturated alkane. So its formula should have 3 carbons here, 1, 2, 3, and each of them are 4 valence electrons, has 4 valence electrons. So 1, 2, 3. So additional amount of hydrogens here is structural formula. When you show each bond between atoms. Condensed formula will show only bonds between carbons. So 1, 2, 3. And for hydrogen, you will need just this CH3, CH2, and CH3 here. Number of carbon, it's 3 here. Number of hydrogen, it's 8. Saturated or unsaturated. A single bonds gives us saturated, so it's saturated. And type of bonds here are single. And also single, yeah. And also for alkanes, you have CnH2n plus 2 formula to calculate the number of carbons. Okay. The next one, propane. Propane prefix is prop. Gives us 3 carbon, but it's alkene, so it's unsaturated. That means that it should be one double bond between carbons. So yeah, each carbon has 4 bonds. So H, 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 H here, H and H. And condensed formula will be CH3, CH, double bond here, and CH2. Number of carbons still 3. Number of hydrogen less than in propane 6, because it's formula for this group of unsaturated hydrocarbons, CnH2n. So 3 2 times 3 gives us 6 hydrogens here. It's unsaturated. And what kind of bonds it has? Single, and double. Okay, the next group, propyne. Propyne gives us 3 carbon, 1, 2, 3, and 1 triple bonds here. That gives us 1 hydrogens here. No hydrogens are at the second carbon, and 3 hydrogens here. 1, 2, 3. And CnH2n minus 2. So condensed formula, CH3, C, triple bonds, and CH. Here, number of carbon 3, number of hydrogen 4. It's unsaturated. Bonds single and double. So, and I write it down again for propanes, CnH2n plus 2. That will help you calculate the number of hydrogen in every group of hydrocarbons. I'm gonna erase this. Okay. Why are alkanes and alkynes and alkynes called unsaturated compounds? They called unsaturated compounds because they don't have a maximum amount of hydrogen. So you will know this in the future if you're going to take more chemistry courses, that they can add more hydrogen in chemical reactions. That's why they are unsaturated. Okay, let's do another one. Identify the structures as an alkane, alkene, or alkyne. So, Alkane has only single bonds, hydrocarbons with only single bonds inside. So this one is alkane. This one is gonna be alkane, and this one is gonna be alkane too, because they are hydrocarbons with only single bonds inside. So blue color I will use for alkenes. So alkenes have double bonds, at least one. So here alkenes for sure, one double bond here, one double bond here, and these compounds has two double bonds here. So two double bonds gives us a sort of alkene too. Okay, for alkyne, I'm gonna use green color, alkyne, and it's only one compound which has a triple bond between two carbons here, so it's gonna be alkyne. The next one. Identify the structures as a cycloalkane or branched alkane. Cross out the structure which are neither cycloalkane or, oh, okay, this is a mistake, misspelling, or branched alkane. First of all, we need to identify types of bonds. So alkanes have only a single bonds. So we can see here double bonds. It's not gonna be alkane at all, nor cyclo alkane, nor branched alkane. It has double bonds here, so we're gonna cross out it. The same double bond here, double bonds. So, and only single bonded hydrocarbons left. So now we need to define, are there cycloalkane or branched alkane? Okay, cycloalkane, it's easiest way to identify them. So it needs to be cyclo. So I'm gonna use, let's say, blue color for them. So cycloalkane. This one is cyclopentane because it has four carbons. This one is a cyclobutane because it has four carbons. This one is cyclohexane because it has six carbons in a cycle. So I'm out of cycloalkanes for now. Now I need to find branched alkanes. So the red one I will use for that, branched alkanes. Oh, okay. So for sure it's branched because this is a chain and these are branches. See? Oh, okay. The next one. This one is not branched alkane because it has only four carbons which are in a straight chain. So I'm going to cross out it. And this one, this is the main chain here, the parent chain, and branches one, two, and three here. That's why it's branched alkane here, and this one too. The next one, consider consider two Lewis structure for a compound C2H7N. Do you think they are the same compound or different compounds? Why or why not? So these are this compound has the same amount of carbons, so 2 carbons in each compound. So its formula go to be C2, right? So 1 nitrogen atom, N, and the same amount of hydrogen, which is 7. So C2 H, I'm sorry, C2N H7. On the first sight, you might think that they are the same compounds, but the order for atoms in these compounds are different. So let's say I have a human person, right? So this is head, this is its body, arms here. Something is happening with my pen, I'm sorry. Arms here and legs, right? So I needed to start again. So I have my human. So one head, one body, 2 arms, and 2 legs, correct? And another one head, one body, but one arm gonna be here, one arm gonna be here, and 2 legs. One legs here, and one legs here. Okay? They have the same number of arms, legs, hands, bodies. Are they the same? No, they're not. Like these organic compounds, they have the same molecular formula, but they are different because the arrangement of the order of bonds is different. So we can see here that carbon bonded with nitrogen, and then nitrogen bonded with carbon. And here we have a different order. So carbon, then another carbon, and only after that nitrogen. And the polarity of these molecules will be different, and the shape will be different. So yes, they are different compounds because of different structure. Okay, let's do another one. Draw the Lewis structure for the following organic molecules. So C2H2. So C2H2. 2 carbons should be connected. 1 carbon, another carbon, another carbon, and 2 hydrogens here. 1 and 2. You know that hydrogen can create only 1 bond. That's why I'm gonna start again. I'm sorry. So 2 carbons, 1, another one, 2 hydrogen. Each of them has only 1 valence electron. That's why it can create, it can form only one single bond. But for carbon, it's not correct because carbon has 4 valence electrons. So these 2 stay here, and if it's only single bond between carbons, so it's not give us it's not giving us an octet rule, so that's why it needs to be triple bond between 2 carbons. So, and you understand that 1 bonds is 2 electrons, so we can calculate the number of electrons around the carbon, each carbon. So 1, 2 here, 3, 4 here, 5, 6, 7, 8. So for each carbon, it's correct, and each carbon has acted on its outer shell. So the next one, C2H4. So two carbon connected to each other, and four hydrogen, two hydrogen around each carbon here. So each hydrogen single bonded with carbon. So and for carbon it has to have four bonds, four single bonds, or okay, four single bonds, four electron pairs. But now it has only 3 that gives us another additional bond. So this is alkene because here carbon double bonded with another carbon. So the next one, C2H6. So carbon and 6 hydrogen around them, so 3 out of each side, hydrogen, 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 and hydrogen. So bonds, and you can see that 4 bonds for each carbon, so we're good for now. So this is alkane because it has only single bonds inside. So this one, 1, 2, 3, 4 carbons here, 1, 2, 3, 4 carbons here, and it's saturated formula. It shows us the order in which carbons bonded to each other. So the chain of 4 carbons here, and shows us this kind of formula shows us the amount of hydrogen. So 3 hydrogen here, no hydrogen here, and 3 hydrogen on this side. Okay, this carbon, the first one, is good because is happy because it has 4 bonds here. The second one is not happy because it has only 2. That gives us additional 2 more bonds here between 2 carbons. So there is a triple bonds now, and that makes 2 carbons in the middle happy because they both have now 4 bonds. So and the last carbon has 4 bonds already, so it's alkyne. The next one, when you see this type of condensed formula, you need to understand that this group in parentheses connected to this carbon in the left. So the chain will be out of carbons which are not in parentheses. So 1, 2, 3, 4 carbons here. 1, 2, 3, and 4 carbons here. So the first one, CH3. So 3 hydrogens around it. 1, 2, 3, 1, 2, 3. We're good with this group. So the next one, carbon here. Carbon, no hydrogen, but CH3 groups here. So CH3 groups here, and no hydrogen. Okay, we're good with this and this. Or CH3 2 times. I'm sorry, so 2 times CH3. This carbon connected to 2 CH3 groups. Okay, we're good to go. CH, another one, CH. So it has hydrogen here, CH. We're good. And in parentheses, CH3, that gives us CH3 bonded with this carbon to its left. And we're good here. And the last one, CH3, is just carbon bonded with 3 hydrogens here. Okay. So it's branched. It's branched. And what types of hydrocarbons? It's alkane because it has only single bonds here. Okay, and I need to do this. H. Okay, let's jump to this one. So we have, you remember, you count only carbons which are not in parentheses. 1, 2, 3, 4. 1, 2, 3, 4 carbons. And let's show hydrogens and branches. So hydrogens. The first one has 2 hydrogens here. 1, 2. Single bonded with this carbon. Okay, we're good with this part. So then next one, the second one is carbon. Yes, carbon, no hydrogen here. And you can see there is only one CH3 group here. Okay, CH3. And please stop on a minute and think about each of them, the first carbon and the second one, has only 3 bonds, but they need to have 4. That gives us additional double bond. Okay, so we good here and here. Another carbon C and CH3 2 times. That means that it bonded with 2 CH3 groups here. And another CH3, so 3 hydrogens here. And pay attention, you can go back and pay attention to the number of bonds which all carbons have. Okay, H2CO. So carbon is going to be our central atom. O here and 2 hydrogens here. So hydrogens, okay. Carbon, okay. For carbon, it has 1 more electrons, and for oxygen too, so it has 2 lone pairs. We know that, and electron. So it gives us additional double bond here. Okay, the next one, CH3O, CH3. So C and O and C. You know, saturated formula shows us the order for atoms. So COC. And each carbon bonded with 3 hydrogen. 1, 2, 3. Okay, each carbon is happy, has 4 bonds, no lone pairs, but it's not finished for oxygen. It's happy having 2 bonds, yes, it's correct, but it has to have 8 oxide electrons, so we need to show it's 2 lone pairs. Now it's correct. The next one, CH3, C, CH3 2 times gives us branches CH3 and CH3, then CH2, CH2, H, H, and then O and H. And I forget to do this, H, H, and H. Okay, so let's check. So the first carbon, 4 bonds, yes, no lone pairs, correct? Octet rules, yes, that's correct. So this one, 4 bonds, perfect. This carbon and this carbon has 4 bonds too. Okay. The third one, 4 bonds, no lone pairs, perfect. Oxygen, 2 bonds, it's great, but 2 more lone pairs here, okay. And hydrogen, 1 bond, okay. The next one, we have the chain out of 1, 2, 3, 4 carbons and nitrogen in the middle. So 1, 2, carbons, nitrogen, then carbons, then carbons again. So the first one, CH3, H, H, H. The next one, CH2, H, H. In the middle, nitrogen, and nitrogen has H, H. For nitrogen, it's not completed because nitrogen has 5 valence electrons and 1 lone pair here and 3 bonds. So now it's completed. So CH2, 2 hydrogens here, 4 bonds for this carbon, and CH3, 1, 2, 3, 1, 2, 3. So this is Lewis structure for this compound. Let's do next one, the last one, I think. This compound 1, 2, 1, 2. So we have 1 carbon, the second carbon. Then the first carbon CH3 bonded with 3 hydrogens here. The second one bonded with 1 hydrogen. Okay, and in the parentheses there is CH3 group that gives us CH3 here, right? And NH2. So it's N here and 2 hydrogen here. Okay, but we need to show its lone pairs here. Okay, this one CH, this one C, this one CH, CH, then bonded with CH3 in the parentheses, CH3, and then CH3, CH3. Okay, first and second carbons does not have an octet of electrons, so that's why they need 2 additional bonds here, and it's going to be triple bond between them. Okay. Okay, we discussed concept checking, and now you need to do by yourself practice problem set 6. And we already did like similar assignment. So we're done for this moment. Please don't forget to download your handouts, and don't forget that you need to train practice exam, and you need to finish exam on its model. And I wish you good luck and see you in class.